All right, we're going to be working on exercise 7.5 this morning, and I've begun by creating a new file. I'm going to go up to the file menu here and do a save as. Uh, as we've been doing in Unit 7, I'm going to actually go up one folder level here. I don't want it to end up in this folder. All of the Unit 7 exercises, each one is going into its own folder, and that's just basically for the ease of keeping stuff separate so we don't confuse which input and output files we're working with, because sometimes we use similar names on them or maybe even the same files. So I'm going to create a new folder here, and I'm going to call it exercise 7.5. And then we'll call the file exercise 7_5. And we'll get a little zoomed in here. So we'll end in the coding engine. And then this is going to be our task here. And I'm just going to paste this into the comments area up at the top. The basic task is to write a program that asks the user for a file name and prints the number of characters, words, and lines in that file. Now, you can use literally any text file for this, but I thought, in terms of just simplicity, I'm going to be using one of those Beatles songs that I captured lyrics from off of Google some time ago. And you can do the same thing. So if you have maybe a document somewhere that you've created, maybe a paper for a class or something, if you wrote a report, or I mean, really, you could randomly grab text off the internet, it doesn't really matter where the text comes from, and then put it into a text file of some sort. What I have on deck are the complete lyrics for the Beatles song Blackbird. If you guys remember, I used this one when we started out, but just a few lines of it. This is the complete song. And you can see I basically went to like Google, and searched Beatles lyrics, Blackbird, whatever, and just grabbed the text right out the screen and dropped it into a text file. Now this is currently stored in a different folder. What I'd like to do here is make sure that that's saved into the same folder. And you can see this is attributed to my fall class, which I don't want. I want the spring class, unit 7, exercise 5. And I'm just going to save it there. And this is just a plain text file. For the most part, I think the punctuation is stricken from this. But you know what? I've done this in the past too. And sometimes I go in here and I remove the punctuation on purpose. And so you see I'm getting rid of the periods. Actually, that is just stuck on my screen and not a period. That's pretty weird. Okay, so here it is. I'm going to do a Control S to save it. So this is the file I'm going to use. But what I'm going to do is kind of something weird here is I'm going to grab all the text here for a moment. And then as I highlight it, I want you to kind of take a look at some of the things that are going on here. First of all, I'm noticing at the end of each line, as I highlight everything, a lot of the lines have a space at the end. Spaces I didn't put there, they just came from grabbing it off the internet. And then I'm looking at how many lines of text I have. So I have 18 lines of text. And we've already kind of figured out an algorithm where we can figure out when we read in a text file one line at a time that we can take that, the whole line goes into a list structure. And then we can take that list structure and break it down further by separating the words by simply identifying that there's spaces in between them. And then if we hit a space, what follows goes into another list item. And so it's kind of starting to show you like why we have lists, right? And remember, we call these arrays in other languages, but basically it's a singular structure that holds multiple values, and that way they're separated and we can address each value on its own. The other thing that we're capable of doing too is recognizing that each word that we break down can be broken down into individual letters, and those are also basically a list structure. All of them have index values, so we start counting at 0, and then kind of building up across the structure. I'm going to grab all of this text for the moment, copy it, and then I'm going to open up Microsoft Word, which is kind of a weird place to go right now, but I'm doing this for the sake of demonstration, to show you that a word processor like this um, has kind of some interesting features in it that we kind of ignore, basically, because they're just kind of so we can consider them almost pedestrian, or in some cases, a lot of people don't even know they're there. So just kind of a helpful little thing. If you're not aware, Microsoft Word, is really the preeminent word processor professionally. So like if you walk into just about any office environment, um, this is, the word processor they use. It's been that way for, roughly 30 plus years now. Um, and prior to that, there were other tools that people used that were really popular. So when I first broke into the IT area professionally, like working, um, I was working at in a university here in Milwaukee, and our standard installation on the computers at that time, we were using Windows PCs that were, I think, predominantly 286s and 386s. I think mostly 286s though, and that tells you what kind of chip was in it and how little memory it had, basically. Um, and our standard configuration for an operating system was DOS. So we didn't even have Windows. It was, and I think it was either DOS 3.0 or DOS 5.0. I think it was a mix of those two operating systems. And then the main pieces of software we used was WordPerfect. That was the preeminent word processor back then. And then for spreadsheets, we used Lotus 123, and some people used Microsoft Works, which is a little bit of a precursor to Microsoft Word and the whole Office suite. It was kind of like Office Lite or something like that. They did actually come out with this piece of software, and the software was Windows based. So, I mean, when Windows 3, 3.1 hit, that was like a huge movement in IT. Word quickly became the favored tool of choice over WordPerfect because it just worked better inside of Windows, and everybody wanted it to be inside of that space. Um, and then it just kind of went from there, right? But Word is really one of these crazy powerful programs. I don't know if you guys, have used it beyond like maybe typing up a paper or something, but you can do so much with this product that you probably aren't even aware of. Um, it's kind of crazy, actually. You can probably work professionally in IT your entire life and still not use all the features within it. I'll just put it like that. Right? Um, so one of the interesting things about Word, and they built these capabilities in over time, and the feature that I'm about to show you is one that actually originated from WordPerfect. So WordPerfect had this capability where you would have the text on your screen, and then, like, for example, you're writing a paper, and in college, very often you'll get a professor, or maybe you guys even get it now in high school, they'll say, I need a 5-page paper with 1-inch margins with 12-point font, and except we'll give you all these parameters. You have to have so many words on a page, and you have to have citations, and it's got to be double spaced, and yada yada yada, all that kind of goofy stuff. And it's not goofy, really, right? They're just setting parameters for you. But we learned pretty quickly, using Microsoft Word, that for example, like if your instructor says, hey, I need a 500 word paper, right? That it had a tool built in, and I want you to notice right down here in the margin, that indicates to you, and you can click on this tool, by the way, and it shows you how many pages you have, how many words, how many characters without spaces, how many characters with spaces, how many paragraphs, lines, et cetera, right? And so it was kind of keeping track. So every time you're typing something in the document, it's automatically running some sort of a code in the background, really similar to the code that we're going to create right now, that keeps track of those things as you're building your document. So kind of a fascinating little um, aspect of Microsoft Word, but most word processors have this feature at this point. I would assume actually all of them do. Most of the preeminent word processors out there right now tend to be clones of Word and its predecessor, Word Perfect, and capabilities that those products brought in professionally. Um, so if you use Google Docs, I know they have a similar feature inside there. If you're on a Mac and you use Pages, that's got a similar feature. And then there's all the what we call the open office variants out there, which are open source office products that have, spreadsheets and word processors and all that. All right. So the reason I do this is because this is really kind of a quick and easy way to verify that our program is working correctly. Right. So we're going to be looking for, do we have like 124 words in this file when we process it, that type of thing. So I'm going to keep this open and in the background, but we'll come back and refer to it just to kind of verify. But the number I'm kind of keeping in my head here is 124 words, 524 characters with no spaces, and 630 with spaces. And then I'm trying to keep in mind that there's 18 lines. 17 of those lines have an extra space at the end, so I could subtract 17 from this, and whatever value that gives me, um, you know, 613 or something like that. But the point is that we have a tally here that we can refer to. So just like you would maybe use a calculator or a spreadsheet to verify your calculations for a program, this becomes a tool to verify that your language processing is happening correctly as well. Now, this is kind of an interesting thought here, but when we start using Python to process text as opposed to numbers, right? Because the last exercise we processed numbers, um, it also becomes a little bit of a precursor um, because Python is really elegant at processing text efficiently, which is another reason why it's used both for data science and, more importantly, for artificial intelligence work. And there's a special branch of artificial intelligence work called natural language processing, where the AI software, whatever software you create, understands the difference between one word and another, right? And in order to do that, it has to do some of the steps that we're doing now, which is to be able to read in the text, break it apart into words, understand that some words may be more meaningful than others. For example, like this word is probably more meaningful than this word, right? Have it understand sentence structure, punctuation, sentence termination, all that kind of stuff. Um, and there are specialized libraries inside of Python that are built for taking in text and processing it and converting it into AI prompts or AI solutions or even into generative AI, which real fascinating. So this is kind of like you can call this baby steps into that world, right? So this is kind of like dipping your toes in the water. But if that intrigues you in the slightest, it's a thing that's going to explode in terms of learning. We're going to be offering artificial intelligence courses starting next spring at Gateway. That'll be part of our data science program. A lot of schools are starting to delve into it, but Gateway is one of two schools in the state on the technical college level. So we're amongst the first in the state to be offering that kind of instruction. I'm working on actually building the courses for it right now, a year in advance, and choosing the textbooks and everything. So if that intrigues you in any way, shape, or form, what's kind of interesting is this course is a prereq to those AI courses. So like if you've taken this course and you got a C or better, you can take the AI courses and either earn our certificate or earn the degree and carry it forward to a four-year school. And I will also remind you, I know a lot of you are probably four-year bound in terms of college, but when you start to look at the price of college, right? And so I'm kind of coaching you a little bit here. college courses get really, really expensive. So you would take a course like this at a traditional university, it probably cost you in the range of somewhere like $2,500 to $4,000, something like that, for one single course, right? Where if you take this at Gateway, it's about $500. And you throw in the textbook, maybe five, six, $700 total. So much cheaper, and the credits transfer, right? Etc. All right, so let's get to working on this interesting little problem here. And remember, this is the file that we're processing, and we have to basically read in the file. And notice it says write a program that asks the user for a file name and prints the number of characters, words, and lines in that file. Right, very similar to what Word is doing. All right, so first thing we want to do is just read in the file, and that's a mechanical process. We've done this already, so let's just put in a little comment here to just kind of indicate that we're doing this. So we're going to prompt the user for this. When we're prompting the user, we will then read the file. We'll create an in file, and we will open it in read only mode. There's no reason to change the file, right? This is kind of my point. We will use a try except statement. So I'm going to say try, and then we'll read it into, well, first we'll capture the file name because we're asking the user. So let's create a variable called file name. We'll use our input command function technically, and then we'll prompt. Enter the input file. Some people have this as 2 words. Some people have this as 1 word. I'm going to use it as 1 word. I think that's appropriate. All right, so we're prompting the user for a file name, and hopefully they enter something. Then we're going to say in file, open file name. That's what they typed in. We're going to turn on the R switch for read only. All right, so let's talk about this, just this little piece of code. This is kind of a very simplistic little piece of code. But what if they don't type anything? Right, we haven't talked about that. What would happen in that case? Would this code run? Well, it would read in nothing, and then it can't open nothing, so it would fail, right? So if it's blank, listen to the way I'm saying that too. Should we maybe ask them to re-enter it? So we haven't done a lot of that kind of stuff, but why not practice it, right? So we will prompt them for the file name, and then what I'm going to do is actually I'm going to do a while loop, and I'm going to say while the file name does not equal an empty string, or actually, yeah, while the file, yeah, that's the right logic. I'm trying to think, is this the right logic? Yeah, so while the file name does not equal an empty string, we'll open the file. Does that make sense? I want you to think about that for a second. Is that the right logic here? And then if it's not the right file name, what's going to happen? Right. I know you guys aren't very talkative about this stuff, but what I would encourage you, and maybe you guys don't get this encouragement in high school, and I apologize for that. Our high schools are like that sometimes. But when I teach my classes at Gateway on Zoom or in person, I encourage a lot of interactivity to help, not for the sake that you guys aren't getting it, but just to see the engagement and see if you guys are kind of in tune with where I'm going with this. Does this logic make sense? Because what happens if it is blank? Then we open the file, but when it's not blank, we open the file. Or what happens if we want them to re-enter it. So you guys see like where I'm going with this. What I want to set up is if the file name, this is actually the wrong logic, by the way. So if you're thinking it's right and you're copying it down, sorry, wrong. Right. The correct logic would be, so while the file name, I'm trying to get equals here, is blank, I'm going to keep prompting them. Okay, so what I'm going to start with then is instead of prompting them here, I'm going to remove this. I'm going to set the file name to blank so that this runs. So in other words, I'm presetting it to force the while loop to run. Right. So I'm going to say, well, the file name is blank. So if the file name is, or while the file name is blank, then I will prompt them to enter the file name. Right. If they press enter, during that process, it's just going to keep coming up, enter the input file name. And you know what? I might have a limit on it. So I could set up a limit while the file name is blank. And then I could do the logical or and say while the count is less than or equal to 3, which means I need a counter variable inside here. So I'm going to give them 3 chances, right? So, and it's going to prompt enter the input file name. They press enter. So every time they don't enter something, I'm going to keep asking them, but I'm only going to do it 3 times. And then hopefully they enter something, right? And then we open that file, and hopefully it's correct. That's the other part. If it's not correct, okay, well, that's where we do our accept. So here, let's do an accept right off the bat and say, kind of a basic or pedestrian kind of message here, like error file not found. And then in many cases, we're kind of done. Really the program should exit out at this point if you think about it. All right. Now, I'm getting an error here. It says invalid syntax. And what is invalid about this? Anybody seeing it? Is this the correct way to do an OR? You guys got nothing, huh? No input on this at all.
Is or just or like
Okay.
the word or?
There you go. Right. So I throw that I'm doing this in a couple of different ways, but now it doesn't like this. Undefined name count. So we're kind of fixing one problem but creating another. Right. So what it's saying here is it's looking for count, and I have count here and I have count here, but count actually needs to pre-exist before the loop. And Joshua, thank you for saying that. I appreciate that you spoke up. Shows me somebody's kind of tuning in. So we have to preset both of these before we go in. And now both errors go away. So we're going to say while the file name is blank or the count is less than 3, we're going to keep prompting the user to enter a valid file name. Okay. The other thing that I can do here, and so and you could make this more and more complex, if you start thinking about how a real program works. What if, I check to see, and I'm not going to actually code this, but another thing that I could check for is I could see if, since I plan to process a text file, I could also check the file to see if it has a .txt extension, or I could check to see if what they entered in was a number or a string or, et cetera. I'm not going to do that, but that's the kind of stuff programmers write in. They would put it in the while loop, by the way. Um, and so we want to give them a couple chances to, because people mistype. I might, oh, my caps lock was on or whatever, right? So you just want to give them that chance to fix things. And then if they do, we'll open the file and read it in. Otherwise, we'll put an error message on the screen. And we could make this way more sophisticated, by the way, but just doing a little simple try except to just kind of make this happen would be kind of helpful. So you know what? Let's try this code and see if it even works. Because um, we're assuming it does, but um, we don't know. Now, what I'm going to do though is I'm just going to throw in a real simple little print message here just for testing, and say test worked, basically. Right. So like, if we're able to read in the file, we'll have a little message. And you know what? We could just actually make it a regular part of the program and say file successfully loaded. Throwing a blank line there. All right. Saving it, hitting the run button. So let's enter the input file name, leaving it blank, leaving it blank, leaving it blank. All right, that's 4 tries, by the way, right? 5 tries, 6 tries, 7 tries. What's happening here? What's what's the flaw in my logic? All right. If your brain says, well, when you do an or, only one of the conditions has to be true, right? And that one's continuously true, right? So really, I don't want an or, you know, um, I need an and here. So I'm going to do and. I'm going to just simply terminate the program. Now, I don't know if you guys are aware of how to do this. We do Control C to cancel, and notice what happens. It forced the program to stop and triggered us out. All right. So now that I've switched it to and, I'm saving it again, trying to run it. We'll try blank, 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 and then it's done. But it's still one too many. So basically, I don't need this. Is 3 tries enough? Yeah, probably. Right. Um, right. Run it again, just to see 3 tries, and we're out. All right. Let's now run it one more time, and this time let's try actually entering, whatever that text, which is not in my folder. Okay, so maybe do we need an error message here? Maybe. Um, so okay, so a couple different thoughts here. Um, if I put the first prompt inside the loop, it eliminates my ability to tell them that the file's not found. So maybe this, and this is actually pretty standard with while loops, by the way. You do the initial prompt outside the loop, right? Because if it works, we would skip the whole darn loop and just go right to the in file. And instead, I'll put a print message here that says, well, what should it say? Error file not found. Um, so I could just do something like this. File not found, and then take the prompt and drop it in here. Let's try this approach and let's see if this logic works. Oh, I guess I got to end that program. Now let's run it. So enter the input file name. All right, I'll go blank. Okay, file not found. That helps, right? Let's just type in some nonsense. File not found. Let's try to make it right. So I'm using Blackbird with a capital V, which it's not. So at least we have some logic in there. but you know what? Let's make it work this time. All right, so I'm going to just very simply, let's say I'll do one incorrect one, and then I will do blackbird.txt. Oh, okay. So now I get it right, and it's still failing. Now, why is that? Is it because of where this message is? You know, and that's really what it is. And it's going to keep doing that. So where's the correction here? So while the file name is blank and the count is less than 3, so both things have to be true. So if they fail, they get the message. We prompt again, right? Both things have to be true for the loop to keep running. Is this the right spot? You're not making you guys maybe think a little too hard today. These are the kind of mechanics that we go through as programmers. All right, so how do I get my way out of this loop? If they enter the file name and the file name is equivalent to blank, so that has to be true, and the count is less than 3, that has to be true. Now, this is where it might be helpful, by the way, to kind of see what's inside of the variables. So I'm going to run this one more time, and I want you to keep your eyes up on that panel there. You know, so if I do type correctly, so got a little bit of a failure here that it's not capturing it. I see what's going on. I don't think you guys are catching it yet. All right, so what's happening is we're prompting for the file name. So we're doing the prompt, but where's the file name going? It's not going anywhere, but we're not storing it. All right, so here's the fix. We have to actually store what we're capturing, right? Because file name is never getting changed. That's what's going on. Yeah, really, it's actually pretty simple. Kind of a little bit of a test on my part. Nobody jumped in to try to fix it though, but whatever. All right, now let's try it. So we're gonna make that terminate. Now we're gonna save this. I'm gonna Control S to save. We'll run again. And now if I type blackbird.txt, hey, it's successfully loaded. All right, let's do it again. Let's make it fail once, maybe twice, right? Now what's happening? Okay, so while the file name is not blank, right? Well, it wasn't blank, and the count is less than 3. So why did this fail? It never hit the loop, right? Should I switch back to my OR logic at this point? Let's try that. All right. Enter the input file name. I'm gonna put in some nonsense. All right, file not, now that makes more sense. File not found. Then I do Blackbird. Now that's telling me that's not okay. So is there a singular fix here? Right. There is. I'm not. You guys just aren't seeing it, and I'm hoping that you end up seeing it. Um, how do I fix this, folks? Is and still correct? I'm going to give you guys a little bit of a challenge. I'm going to let you think about this for about 5 minutes. I'm going to pause the recording and then we'll see if you can come up with a solution. The solution is not far off, basically. Um, but we're really, really, really close. I'm just trying to see if you guys can figure it out. So I'm just going to pause for a moment and see if you can figure it out. Give you a Zoom recording. And all right, so we did a little bit of work. We did a combination of trying different things. We experimented with some different code, for example, and Joshua found some code on the internet that he shared with us, which basically had this try with the 2 file errors and the IO error and the maximum number of attempts. So I'm just kind of leaving all this code on the screen because this is all of it. And then we inserted our logic for breaking apart the problem. I'm just actively starting to run it down here. And so let's see if this works. So I did one attempt here where I entered a false name, no name, no name, and it did exit. Now we're trying the actual attempt to get it correct to see if it actually processes anything. And there it is. So the file contains 647 characters, 124 words, and 18 lines. And then once again, how does that compare to Microsoft Word and its word count? Well, we have 600 characters with spaces. All right. So we have a discrepancy of 17, but that 17 comes from those spaces at the end, which Word is not counting, but we are, right? So we're counting those spaces as characters. If you wanted to make it jive, you could just remove those, or you could write code to overcome it too, but that seems a little cumbersome. But basically, I'd say the code is working. It prompts, it gives us the way to, at some point quit, not crash when something wrong is entered. And then if something correct is entered, it does the work and makes it all work. It's all within try except statements. It's within a giant loop. And basically the flaw in our logic here was that we really needed to put all of this in a while loop, right? So we could re-engineer it, but we are running out of time. So I kind of want to shift gears here. So I'm going to call this the solution for exercise 7.5b. And if you guys are, trying to get all of the code in, you can probably screenshot this. I did give you little bits and pieces in the chat as we were working, but see if you can get it to work. And then if you want to have a little bit of fun with it, go out to the internet and grab, some song lyrics or maybe a paper you've typed up or something, put it in a text file and see if you can process that and see how it matches up with the word counts, line counts, and character counts in Microsoft Word. See if it works correctly. All right, so we're going to end this video here.